The placebo effect is strong for sure. Definitely strong. All right, should we move on to some new stuff and then we'll talk about the next project? Are I all just like broken and tired and done? That's sad. That's sad. It's okay. How about we just talk about interfaces and some testing that we didn't get to yet, and then we'll talk about the project. These other ones are fun. You can look at them. I trust you can read. You guys got to college. You can probably read by now. Probably a skill you have. Stop this lamp. Okay. Oh, man. It was so bright. I should have turned it off earlier. I've got a headache now. So interfaces are tons of fun. Very widely used in C#. An interface, for lack of a definition here, is a pure abstract class. What you might be familiar with C#, C++. Remember, in C++ you can write abstract functions where you have a function that doesn't have a definition. You say it equals 0. It's an abstract function. And then you can have a class full of abstract functions, a pure abstract class, where it says, here's just a bunch of functions I will have. Doesn't seem super useful, but once we start talking about polymorphism and inheritance, and I can treat my classes as types they inherit, we see that, hey, these are actually really cool. So what we get is essentially a contract. We say, hey, if I implement this interface, if I am this interface type with inheritance and polymorphism, I will have all of these methods. You can use me as this type here, and I'll take care of the details. When I write a class that implements an interface that inherits from this pure abstract class, I'll do all these things. So it's super useful. We can do lots of fun stuff with it here. We're going to do a silly example first, because that'll be useful for our testing here. Now, if we wanted to test our Yahtzee dice class here, right, all this logic we did for getting the scorecard out, right, this is essentially the meat and potatoes of what we wanted to test. Can I calculate these things correctly? We don't have a good way to do that because all of the scores are based off of our dice, and our dice are all based off of random values. Right? When I roll, I get some random values. That's the only way it works. It's either 0 or have some values. I don't have access to dice values to change that. Right? So there's not a good way to programmatically test this without rolling a whole bunch of times and throwing them away and rolling a whole bunch of times and throwing them away until I get the values I want. We could do that. That sounds awful. And that is awful. We shouldn't do it that way. So what we can do is, because Yahtzee dice is dependent on random, right? It has a dependency on this class called random, right? We're going to do this cool, what do we call it, a design pattern that says we're going to do dependency inversion. We're going to invert the dependency. So instead of being dependent on random, I'm going to give it a random to use. So instead of it generating its own random, I will give it an instance of random for it to use. Right? So if I give it a random here, I can say my random equals random. Right? This dot random equals random. This could work for us. Now I can give it random, but random is still random. It doesn't work for what we want it to do here. So what we can do is we can generate an interface. We can write an interface that has a method for next that we're going to use here. So I can say, hey, give me an I random here. And this doesn't exist yet, so we're going to go write a class for it here. So we're going to generate an interface, I random, in a new file. So interfaces in C# almost always start with a capital I, because this is what we like to do. We're very convention-based people. So what we need is in method for next that takes a start and an int for end. Right? Start value, end value. And this is really end not inclusive, because I'm obnoxious with my variable names. Right? This is what it does. So now my Yahtzee dice works, except for we need to change this attribute here. Where did it go here? Our code is a little bit messy here, but this is I random now. So in interface random, or I random, here called random, if you pass it to Yahtzee dice, it will go work here, and this next function works because there is a function in the interface called next that takes 2 integers, right? Start and end. Now, what doesn't work yet now is our code, because now I can't make new dice every time, right? When I try and make new dice here, it says I can't make dice. I don't have a constructor here. I need to give it random, right? I have to give it something that implements this interface. Now I can't give it the class random here. Or I can. No, it doesn't like it. Right? Random doesn't implement the interface. Can't convert. Doesn't work here. And that's okay. We'll get there. So what we can do is we can make another class here. This starts to get silly, but it's okay, I promise. It'll be okay. We'll call this actually random. Or maybe it might be better to call it random wrapper. Wrapper probably a little more conventional here. So make this a public class random wrapper, and we say, hey, we will implement the iRandom interface. Right? Looks just like inheritance. We say I am a this type here. What's cool with interfaces is you can implement a gazillion interfaces, but you can only inherit from one class. So you can implement 50 different interfaces if you want. You say, I'll match these 50 different contracts. I'll fulfill them. I will have these methods. But you can only inherit from one base class, one superclass. Unlike C++, where you can mix and match and do all sorts of crazy things. That gets messy. But here, now it says, okay, well, you said you did, but you don't. You said you'd implement this interface, but you don't have the method. You don't look like you do yet. So we can click our little button and say implement. That's great, okay. Well, I don't really want to throw a not implemented exception, but it works here. What I'd rather do is give you a new random value. So we can make a private attribute, private random, and then we can make a constructor, random, please, there we go. Make a public random wrapper, say random equals a new random. There we go, some parentheses. Okay, so now when I go to get the next value, I'll take my random.next, given the start and end inclusive, and I'll return that. Whole bunch of work here. I wrote a class that uses random because I want to match the random interface here. We haven't done anything useful yet, but now what's useful is now when I want to go add tests here. Now I can actually add some tests. So if I go and I say, what is it? Scroll down here. Go to create unit test. Here we go. Let's make unit test here. Sure, that's fine. We'll probably do what we wanted to do here. We talked about tests, right? Yeah, we did. Okay. So you're not going crazy yet. So now I can do my get possible scores test here. Now in my test class, I can go add a new file here. This is not random. Not random can implement the iRandom interface. Right? And it says, oh, no, you don't. You don't implement that. I say, oh, yeah, sure we do. We implement. Okay. Well, now with not random, what I want to give not random, when I create an instance of not random, is a list of numbers. I want to give it a list of values. Now this one can store values. This one they have a list of integer for values. And I say my values equals your values. If only it's that easy to change people's values, right? Here's your values. That was a bad joke, sorry. Anyway, so, and now we probably have, what, an int for current value index. Starts at 0. And when I want the next number, I'm going to give it my values at the current value index, plus. I can return that. I match the interface. When you ask for a next number, give me a start and end, I'll give you an integer back, right? That's all the interface said we were going to do. When you ask for the next number, I give you an int back, right? The random wrapper actually gives you a random or pseudo-random, right, based on the random class. My not random doesn't give you a random value. But now when I want to test my Yahtzee scorecard, I can use my not random class that implements this interface, and my dice are happy, right? So I want to make some dice here, so I'm going to arrange, I'm going to act, I'm going to assert, right? So to things I need to test with, I need a not random. Values equals new not random, and I'm going to give it a list of ints here. So I want 1, 2, 3, 4, 5. 3, 4. Where's the comma key? Come on, comma. New list of int. Not that one there. New list of int, right? Now I can make dice here, so Yahtzee dice. Dice equals new Yahtzee dice. Yahtzee dice. New Yahtzee dice. Given my values. Right? The Yahtzee dice constructor says, okay, if you give me something that implements iRandom, I'm good to go. I'll use it. Right? It has a function, it has a method for next, and should give me something. Right? So I can make my dice, and then I can roll my dice. The values for the 5 dice should be 1, 2, 3, 4, 5, because that's what I gave it here, right? To my not random class that implements the iRandom interface that has a next method. Whole bunch of nonsense here, but we made an interface that has a method for next. We have one that actually wraps random here that we use in our code. So in our code, when we create this set of dice here in our form, right? What do we do that in our form code? We gave it not new random, we can give it new random wrapper. Random wrapper. Right? And it will use random stuff. So in my actual production code that I ship, I'll use random numbers. When people play my game, they get the random numbers. When I'm testing, I don't want random numbers because I can't test random. Or not very well, at least. So that's a little hard to test. So now we can act and we can assert. So I have int first value is 1. Int second value, I'm sorry, not 1 here. I'll have my expecteds. So I'll have, I don't know, we can do list of int here. Int for expected values. Do this. Equals this one here. Give it the expected values, and I'll have an actual first value, right? Dice dot die 1 value, and actual second value is my dice dot die 2 value, right? And on and on and on. We would do more of these, and eventually then we can assert. We can say assert equals, or no, assert dot are equal my actual first value and my expected first value. Expected values of 0, sure. First index, right? Same with the second. Nope, undo that one. Here we go. Too many weird spaces here, sorry. 1 matches my second. And on and on and on. We would do all 5, right? Eventually. This one's not very exciting, but this should show that when we give it 1, 2, 3, 4, 5, we should get 1 and 2 as our first values. And it passed, right? Test passed. Now again, this is not really what we want to test. We're not testing this piece of it here. What we're testing is our scores. So I should have a bunch of expected scores in here, right? So for this roll here, right, my int expected 1's score should be 1. My expected 2 score should be 2. Right? 2 score. 3 score. 4 score. Expected 5 score. And 6's score. Right? It should be 1, 2, 3, 4, 5, and 0, because I don't have a 6. Right? I don't need any of these. I'll have an int actual 1's score. Dice dot. Probably want my expected scores in here then. So Yahtzee scorecard, scores, actual scores maybe. Actual scores is my dice dot get possible scores. Really, I guess that's what we're testing in here, right? We probably put it in here. And then does my actual scores then of 1 score equal my expected 1 score? Right, and go through to check the 2s, the 3s, the 4s, the 5s, and the 6s. 2 score, 3 score, 3s score, the 4 score, the 5 score, and the 6's score. Right? Expected 1s and 2s, and 3s, and 4s. Oh goodness, I got too much there. It's a bad copy paste. Expected 5 score and 6s. Why is it red? Shouldn't be red. Okay. Right, so this is what we're testing. We're testing our get possible score. So we've tested the uppers here. Let's run our test again here. Run. Not debug, I just want to run. Oops. That's fine. Run the test. And it passed. So we got out the score. So if I give it 1, 2, 3, so I say, when you call for the next random number, give it 1, 2, 3, 4, 5 in that order, it should work. Right? So then I can test all my other things here as well, right? I can do, so I should get zeros for full house, for 3 of a kind. Like I can assert all those are zeros if I wanted. Again, testing all the negatives is a little bit obnoxious versus just testing the positives. We still get 100% code coverage, but we could still have bugs, right? I could have a false positive. If I get correct positives, but I get false positives, I have bugs, but I haven't really tested for that. Because we didn't want to test, was it all 252? What was it here? What do you say, 252 possibilities or something like that? I don't want to do all 252 possibilities, and I think you've lost some return at that point. If you're spending too much time in testing all 252 combinations, that feels bad, right? It might be nice, but that's a bit exhaustive if we go there. So the other things we can test then, right? Maybe we give it a, so this is test upper section, right? Maybe we do another test here for the lower section, or test specifically, how about, what, 3 of a kind, maybe? 3 of a kind. So if I have 1, 1, 1, 4, and 5, I just have an expected 3 of a kind is 9, 12, right? So 3 of a kind here. I expected 3 of a kind score. Sure, that one should run. Let's see what passes. And it passed. We're feeling okay so far. So this is one way we could test if we don't want to make our dice have public sets, which is probably a good thing to not have public sets here, right? So what that lets me do is my code that I wrote only has working pseudo-random numbers, right? Because when I create an instance of Yahtzee dice in my form class here, where my code go, form F7, I give it the random wrapper that I wrote. So in my code, I control what gets sent here. Right? Great. In my test here now, I have garbage test code, and when you package things for deployment, right? Right now when you do debug, everything goes to that debug folder, right? But you can set up a build process in your build setup here. You're somewhere in here, configurations. When you do deploys or releases here, you can exclude certain projects. You can say, when I build a package for release and actually build an executable I want to ship my customer, don't include any of the test stuff. Not only does it take up extra bits and space, they don't need the test code, right? The more code you give them, the more they can look at. Because C# code runs, it compiles to that intermediate language that runs in the .NET runtime, you can decompile C# code, right? So the more code I give them, the more they decompile, the more nasty stuff they could find in my code. Right? So doing this is a very silly way to use an interface, but it's a very common thing to do. Turns out it's so common that there's libraries that automate this stuff for you here. So there's this cool library, C# mock, I think it's mock setup here. So why? Thanks, okay, sure. Is it mock? I thought it was mock. No, MOQ. Did I spell it wrong? No, MOQ. MOQ mock tutorial. Let's see if there's a good tutorial. riptutorial.com. Sure. So you can download this library for mock here. And then when you go to test something, we haven't really looked at what these things do yet. We haven't got to Lambda stuff. But you can give it an interface. And you can say, when you call this thing, give this back, without having to write another actual class that wraps all of it. So it lets you save a little bit of time, energy, and effort. So you need the interface and the actual implementation. You don't have to write the fake one and go through all of that. You can mock stuff, which is fun. So like, hey, I'm going to mock this thing here. When I want this property, I'll give you back, here's the value. I go make my test to test it here. I can go set up my value, and I can check, did I get what I expected? Which is lots of fun. It's kind of cool. So this is a very common practice to do this and do this with tests and to do this dependency inversion. Say, if my class depends on something, I can pass it in instead of have it create it here. There's all sorts of other cool stuff you can do in C#, dependency injection. So with dependency injection here, instead of having to even pass it here, you can go and get the values back out. Here's our example here. So when you create your project, you can add something here and say, hey, the iMessage writer you're looking for, use my message writer class. Go for it. And then when you want to go get that one here, you can go get that out of your dependency injection service. There's all sorts of crazy stuff here, but it's okay. So one of the great things, like if I want to do logging differently, I can give it a bunch of different loggers. I could have a logger that spits out stuff out to the console because someone's looking at it. I can have a logger that writes to a database. I can have a logger that sends stuff out somewhere, anywhere I want. So I can have different logging implementations here. So I can give it one particular logging implementation here, and I can just go get that logger back out with my dependency injection. There's some better examples in here. Like, get the service here. Get me whichever one you've injected here. I'll just go grab it, which is fun. So you might add the console message, you might add the logging message, you might do something else here. We can add a bunch. So we can look at those more fun examples later. But this all sets the stage for all this really cool stuff we can do, because it's a very common practice that saves us time, energy, and effort to do it faster without having to do all the hard stuff the hard way. Right? So like we did with the getting out the random values, you didn't have to use any of this crazy null checking stuff. You didn't have to use any of the methods. Right? This is one option, and using some of that cool syntactical sugar, right, made the code a little cleaner here. Where was all of our scorecard, right? We said, hey, if it is null, give me 0, otherwise give me the value, right? We could have done it the longer way, but we get some shortcuts here with our syntax. We get some shortcuts with our tools here to give us a little bit of speed to make this faster for us, which is really fun. Like the upper bonus, we didn't have to write it in one line here. This comes out a little bit faster if you're doing it enough that you can do it in one line here, and it's cute. Again, it's not better because it's less lines of code. It's just, is it readable? Great. The whole goal is we get nice readable code, right? Because code's for people. C# happens to be able to read it too, and that's kind of important. It can read it and understand it. But we want to write code that people can read and that people can understand, and you're people too, right? I'm people, you're people, we're all people. We're a happy family. Sing the Barney song? No? Okay. Do you have scars from Barney too, or is that just me as an old person, an older millennial? No? Okay, that's fine. Those are my nightmares. Right, we didn't need to use knowables here. We could have had other values, like, hey, have they been scored or not? We could have tracked more pieces of information. We're just sort of using the fact that they can be null or not, and that null could represent something. Just different ways of storing stuff. Okay, so interfaces are lots of fun, and then they let us use polymorphic behavior, because I can say, hey, I want an interface that does this. I don't care what the implementation is. So his example in the book is actually really cool. When he goes through and checks out his interface here, he says his interface is a level builder. It will give you back a level here for a given level number. So if you're building a game, that game might want something that is a level builder to build its levels on. It doesn't care what it looks like. So then I can write different implementations for this interface. I can have, hey, here's a fantasy level that you're going to play on. And it gives you all sorts of interesting fantasy things, fantasy characters and whatnot. Or maybe you want a sci-fi version. Maybe you want to go Warhammer 40K. Let's go sci-fi, right? I'll build a sci-fi level builder that implements, when I give you back levels, they're sci-fi themed, right? Or maybe we'll do like a mafia style right? Was it 1920s style level builder? We'll give you back a bunch of gangsters with their Tommy guns. We can build that theme out. So if you have an interface, here's the contract, it says, I'll give you a level. It doesn't control what kind of level it gives you. So you can write different implementations, but the code behind the scenes on how you play the game is still the same. Hey, give me the level that you generated, and I'll spit out the description to the player here. All right, here's the monsters that you find. Here's the weapons that you have available to you. Here's whatever we put inside of level, we can generate on the fly. So my actual level builder then that implements the level interface will give you a level, right? And we can implement this however we want with different types of level builders. So it gives us flexibility over what we actually implement by saying, I'll figure that part out later. And I want to have a bunch of different types of this eventually. You get all sorts of fun design patterns and build factories that build things and that sort of stuff here as you go. But like level might have, okay, this is terrain, sure, and there's a height and a width here. We got different terrain types for this game here. Well, this one sounds like it's Catan almost. You got deserts and forests, mountains. We're gonna get our ore and wood and sheep, right? Catan fans, anyone? Is that old now? Catan's fun. You can only lose so many times though before you just get crushed. So you build out interfaces. Right? And, okay, now this one has terrain at certain types, and now we've got a level here. Right? So interfaces give us some flexibility in not having specific implementation behind the scenes. We can change it up. So testing is one common use for that as well. When managing our dependencies and putting wrappers around dependencies, it gets crazy. It's okay. All right, we got to talk about the next project. You're super excited, right? Everyone's very excited. Does anyone like poker? Fans of poker? Texas Hold'em in particular? Okay. It's not so bad, I promise. It's fun. Texas Hold'em is a lot of fun. So, my brother, he's the reason I got into computers, because I like computers. C# template. Where'd it go? Oh goodness. Can't type my own last name here. There it is. So if we look at building a Texas Hold'em game in an object-oriented approach, life gets really easy because we don't have to do as much work. So it sounds like a lot of work to figure all this stuff out, but I promise you it's not so bad. So we'll go through and I'll build out some interfaces next week to get you started here. I'm running out of time. I thought I had more time, but that's okay. Where's Canvas? So we can take a little more time on this if we want here. I don't think we'll have to have it in 2 weeks because we can have some fun with this one. So we got a little bit of time to play with it here. So let's do project 3, Texas Hold'em. So we've got break and then we've got the midterm. Can we have it do the week of the midterm? Is that okay? I mean, I'm not even going to be here actually. We could go out to the 14th if we want. I feel like if I set the date that far out though, no one's going to start until the midterm, and then I'm not actually helping you. Is this bad? Is this okay? Would you rather have it due in 2 weeks? I'm sorry?
When is the break?
So we've got 2 more weeks worth of content, and then we've got the break, and then we've got the midterm. Right? Let me take a look here again. Oh, I've got it in the website. Why did I got it right here. Yeah, so we've got 2/29 is break, and then the midterm's 3/7. So we'll have 2 more weeks of class. Oh, I'm going to give you some starter code next week. We'll look at some advanced features and give you some starter code for a poker hand. Poker hand is the base that you use in Texas Hold'em, but what's fun about Texas Hold'em is you have 7 possible cards, and you get to find your best possible poker hand. Right? Turns out there's 21 combinations you can make. There's 21 possible hands you can get given 7 cards. So 7 combination 5 is 21. That's in my head because I like this one. I do this one a lot because poker is interesting. Right? Yeah. So we can do more time. Is more time helpful?
I mean, I'm not like a lover of more work, but is there nothing like else for us to do over the next month and a half?
Is it really a month and a half? I mean, so that'll be the next project, and then once we get the databases, we'll do a database project. So ideally, this was going to be due the 22nd, so you had nothing to do over break.
Yeah.
But I feel bad like making you rush forward and then making you have nothing to do over break. So if you want nothing to do over break, do it in the next 2 weeks. Is that fair?
Yeah.
Okay. So we'll do that. And this will be 20 points here. The URL of your repository. All right, so if you want to work in pairs again, fantastic. If you want to make it a trio, I'm open to that. I'm okay with trios. It's probably better as a pair. Like if you start splitting things too far, it gets tricky to work on and coordinating here. So we'll do that. And then if you just close your eyes for a second here and pretend I'm not copy pasting, life will be better. You'll feel better about it. I'll feel better about it. But it's a fun assignment. So we'll go and take Texas Hold'em here. Oh, I had 30 points last time. Okay. All right. Where did it go here? Okay. So up to 3 if you want. I'm okay with that. So we're going to play a 1 versus 1 Texas Hold'em game. Why this link is so annoying. Texas Hold'em. Okay. So with Texas Hold'em, it's a poker variant here. All sorts of fun stuff here. It gets trickier. We're only playing 1 versus 1, so don't worry about the blind thing. We don't have to worry about any of that. We don't need any of that crazy thing. We're just playing 1 versus 1. So the way that cards work, if you haven't played poker before, is you have set types of hands that do better than others, right? So the worst possible hand you can have is a high card. Just the highest card will win, whoever has the highest card. If you don't have any of the other types, you can have a high card hand, right? And aces are high, is the easiest way to track this here. The next hand you could have is a pair, right? 2 of the same card, or 2 pairs, or 3 of a kind, or straight, or flush, or full house, or 4 of a kind, or straight flush. Some people like to add in here royal flush, but that's still just a straight flush. It just happens to be ace, king, queen, ace, king, queen, jack, 10. Ace, king, queen, jack, 10. Yeah, it's just the 5 highest cards. It's still just a straight flush, okay? So those are the hands you can have. But with Texas Hold'em, what happens is you'll get 5 shared cards on the board, and you have 2 cards. So each player has 2 cards, and there's 5 cards eventually show up on the board. There's a sequence we'll do for this, and we can talk about that. But at the end, when you finally are ready to see who wins, you've got 2 cards, they've got 2 cards, there's 5 shared cards. You make the best possible hand you can make out of your 7 cards. They make the best possible hand they can make out of their 7 cards. It's possible you make the same best hand. If the 5 cards in the middle make the best hand, you both have the same best hand. It's a tie. That's fine. But you might have a better hand, given your combination, 7 combination 5, than their 7 combination 5. You might have a better hand, so we'll see who wins. Okay? So you make your best possible hand, see who wins. Okay? That's how that one works. So we're going to start with $100 and figure out how much money they have. Right? So both players have $100. We're going to start with our 2 cards, so we're going to skip a couple things. We just start with 2 cards. You get your 2 before you bet. We're changing the betting rules because the blind stuff is a little bit obnoxious. So the players can bet. Player 1 bets first the first round, and then player 2 bets first the second round, and alternating on and on and on and on. Okay? You can bet or you can check. A check is just a no bet. You say, I don't want to bet anything. That's what that is. If the player bets, the second player can call or they can fold. If they call, they also bet the same amount of money, and the next step will happen. If they fold, they give up, and the player who bet gets all the money in the pot. Right? If the other player checks, you just go to the next card right away. Okay? If the player calls, you put 3 cards on the table. You have 3 shared cards, and then there's another round of betting. And then a 4th card is put on the table, another round of betting. And a 5th card is put in the center, the last round of betting. Then, if there's a call, you figure out who wins, right? Using your poker hands, okay? So we're going to implement this interface called iComparable for a given poker hand. So iComparable is an interface that's used to compare things. So if we write a class, let's start a new project here. So here's Texas Hold'em. So if I write a class for poker hand, add a new class, call it poker hand. The iComparable interface, given poker hand, says I will compare myself to another poker hand and tell you in integer A positive number means I'm greater, a 0 means I'm equal, and a negative number means I'm less than. Right? So positive is greater, 0 is equal, and negative is less than. So what you can do, if you have something that is comparable here, not this one in my form, oh goodness, I need form code, sure, why not? I can make a list of poker hand, equals a new list of poker hand. I can take my list and I can add a new poker hand, and if it's comparable, I can sort it without it crashing. So sort will sort them using the comparable interface. This is how sort works in C#. So if your class implements comparable, life is good. If it doesn't implement comparable, it's no good, it won't sort here. So if I comment this out real quick, let me give it a run. Oh, did it sort? Uh-oh. I don't know if it actually sorted here or not. Sort. Add. That's fine. It won't. So if we have the sort in here, it'll sort like we'd expect. Right? What we want to do. So we can compare two hands. Right? If I give it two different poker hands, and I get back player 1's hand is greater than player 2's hand, player 1 must have won. Their hands are greater. Right? So we're going to implement this iComparable to compare to that does all the work of finding out which hand is better than the other, evaluating a hand. Right? Checking all the ranks. So poker hand needs a way to figure out what rank it is and compare to another poker hand. Right? That's just 5-card poker hands. That's easy. And we'll work through that. I can give you this one. It's okay. We don't have to do this is not the interesting piece here. Right? Then what you're going to do is we're going to excuse me, add in the class for Hold'em hand. Hold'em hand has 2 cards here, and it needs to have the 5 shared cards. So each player has their own Hold'em hand, and they share the shared cards. Right? That will give them 7 cards. So you get 21 possible poker hands, and you find the best possible poker hand from there.
So like where they place it?
So you have to generate all 21 poker hands and find the best one of those to see which one wins. It's not as bad as it sounds, I promise. Okay? So if we implement iComparable with poker hand, we can put all 21 on the list and then just sort. When you sort a list, you'll get the smallest at the front, the biggest at the back. Right? Or you can just loop through and compare each of them yourself to see which one wins. Right? Let me go and grab, where did I grab that from here? So we get 10 points for doing object-oriented design. Let me do this here. This one won't be as bad, I promise. Won't be as bad. Let's do project 3. 10 points for that one. My Hold'em hand class for 5 points, and my Texas poker hand class. Okay. So if we make poker hand comparable, oh, that's why this garbage here. Why does it do that when I copy paste? It's like I shouldn't copy paste. It's so fun though. Poker's fun. All right. So the poker hand class, if that's iComparable and compares poker hands, when we write a Hold'em hand class, we can make Hold'em hand comparable to another Hold'em hand. And we can figure out which one is better as well. So eventually, if we wanted to make this an n-player game, we can see who had the best hand. That way, instead of just 1 versus 1. Does that part make sense? So if we follow our object-oriented design, I thought I got rid of that garbage. I did not. Design. Okay. So if everything is comparable, it's really easy to see who wins. So the hard part is figuring out how we compare them. But if we know how to compare poker hands, comparing Hold'em hands is actually pretty easy. We generate all 21. We figure out which one is the best because these ones already compare themselves. And I compare myself given my best possible poker hand. We'll talk more about it next week. So don't sweat it too much. And life will be good. Okay? We'll have some fun here. Do some images, because images are fun with this one, if you want. If you don't want images, that's okay. You can do it in text. It's not the end of the world. I'll show you how we can do some images next week as well. I thought we'd have more time today, but I ran out of time. It's kind of fun to do images, and then it looks really pretty. Okay? All right. It's been fun. I will see you next week.